Okay, now we have addition and subtraction of large numbers. Now we can start talking about multiplication. And my favorite thing to explain multiplication is called the area model. The area model of multiplication. It's sort of turning the usual method on its head. Usually we explain what multiplication is. Usually we say it's repeated addition. And then we say, oh, when you get to geometry, you say the area of a rectangle is obtained by multiplying base times height. This entirely reverses that. When we say, what is A times B? A times B is the area of a rectangle that has a base of B, let's make it capital B, a base of B and a height of A. For example, if you want to do 3 times 5, well, it doesn't matter which one becomes the base. That is the area of a 3 by 5 rectangle. And you can count. There's 15 squares. 1, 2, 3. And you can look. It's either 5 plus 5 plus 5 in rows, or it's 3 plus 3 plus 3 plus 3 plus 3. It's either 5 columns of 3 added all up, or 3 rows of 5 all added up. So the usual method of 3 times 5 is 3 5s or 5 3s still works. But this is very, very powerful for explaining long multiplication. And, a lot of people will say that 3 times 5 is 5 plus 5 plus 5. And they teach skip counting. They keep counting by 5s. But then, when they get 27 times 63, they don't say that it's 63 plus 63 plus 63 27 times. Here, this is the person thinking about that and thinking, blah, I don't like that at all. No, what do? Let's use the area model of multiplication. The area model of multiplication says that 27 times 63 is the area of a 27 by 63 rectangle. Now, that doesn't particularly help because why? Well, it requires us to know what the answer is. But we can split it up. We can use the positional numbering system. 27 is 20 plus 7. And 63 is 60 plus 3. So 60 times 20 is, well, that's 6 tens and 2 tens. That's 12. 10 times 10, 1200. 3 times 20 is 60. See, because look at this. This is a little rectangle. This is a 7 by 3 rectangle. What's the area inside? 7 times 3, 21. 7 times 60 is 420. And so, 27 times 63 is that whole area. It's 21 plus 420 plus 60 plus 1200. And you add these all up. 1, 4, 10, 5, 7, 1,701. The usual method, 63 times 27, is just the same. We say 7 times 3 is 21. There's the 21. Now we just put the 1 here, we carry the 2. That's the same one as this, and this 2 is being put in a reserve. Why? We then say 7 times 6 is 42. We add the 2 and we get 44. Well, here's the 42 plus the 2. All we've done is we've added those 2 rows together. Similarly, watch this. We say 2 times 3 is 6, and we put the 6 under the 2. It's in the tens column. It's really a 60. It's really this 60. And then we say 2 times 6 is 12, and we shift that over 1, and that is your 1200. Ooh, actually we put it right next to the 6, don't we? We put it right there. And that is these 2 rows added together. And you add this all up. 1, 10, 1,701. So it's pretty powerful. Most people I've known, I was not taught where this came from. I was just taught to do it. You multiply the 7 times the 3, you get 21. You put the 1 down, you put the 2 up. Why? Shut up. It works. This is the way we do it. I think this picture helps explain it a lot. In fact, this area model helps explain multiplying fractions as well. Watch this. Let's say you want to do 2/3 times 4/5. That is the area of a 2/3 by 4/5 rectangle. Well, what's that? Well, okay, what's 2/3? Well, it's not even a whole one. If this is a 1 by 1 square, 2/3 is what happens if you divide it up into 3 equal parts. I've divided it into thirds. This is 1/3. From here to here, that is 2/3. And in order to get fifths, I have to divide this up into fifths with 4 lines. And this is 4/5 from there to there. So when we talk about a 2/3 by 4/5 rectangle, we're talking about this rectangle. And what is this? 2/3 times 4/5 is, what is that area? Well, it's 1, 2, 3, 4, 5, 6, 7, 8. It's 8 pieces where it takes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 to make a whole. It's 8/15. And if you notice, 2/3 times 4/5, the shortcut is you multiply the tops and you multiply the bottoms, and that's how you get your 8/15. Really, really super cool. In fact, this even works for algebra. This works for algebra. I didn't explain this before. When you multiply units, you just put them together. What do I mean? I mean 3 apples plus $5 equals can't be done. You just leave it as 3 apples plus $5. But 3 apples times $5, and that would be kind of hard to figure out a real life situation where you'd be multiplying it. You just smash everything together. You've got a 3, you've got a 5, it's 15 apple dollars. I don't know how to multiply apples by dollars, but apples times dollars is apple dollars. If you have 3x squared y and you multiply that by 4xy to the 5th, what is this? You can multiply the 3 and the 4 and you get 12. X squared means x times x. With another x means you have 3 x's. X cubed. Y is 1y and then 5 more y's makes a total of 6 y's. With that said, we can now do things like multiply 3x squared plus 5x plus 2. We can multiply that by, let's say, 2x plus 4. This is what? It's the area of a big rectangle. And one side of the rectangle is 2x plus 4, and the other side is 3x squared plus 5x plus 2. How do we split it up? 2x plus 4 is 2x and 4. 3x squared plus 5x plus 2 is 3x squared plus 5x plus 2. And now, what's this? It's a 2 by 4 rectangle. Clearly, this is not to scale. 2 should be half the size of the 4. But 2 times 4 is 8. 4 times 5x. I don't know what the x is, but 4 times 5 is 20, and we just leave that x there. 4 times 3x squared, well, at least we can multiply by the 4 and the 3 and get 12x squared. 2 times 2x is the area of this little piece, and that is 4x. Now this is where it starts getting a little bit interesting. 5x times 2x, we can multiply the 5 and the 2 and get 10. And then we have 2 x's. X times x is called x squared. 2x times 3x squared is 6x cubed. And so the answer to this whole problem is what you get when you add all 6 of these pieces together. And let's see, we have 6x cubed. We don't have any other x cubes, we can't add to it. We do have 2 different x squareds. 10x squared and 12x squared is 22x squared. 4x and 20x is 24x. And then we have 8. Not necessarily so tricky.